All right, let's take a look at Algebra Set 1, Problem 5. Determine the number of real solutions each equation or system of equations has. And I want to point out the word real, no imaginary solutions allowed. And let's just take a look, orient ourselves. This one over here, this one here, these four all are X and Y variables. So we'll think of them as graphs, and we're essentially, a solution is when the graphs cross. And these over here, they're just a single system and a single variable. So we'll just solve how many solutions there are normally. Um, we could start with the bottom because that's just a quadratic, right? We can see it's a quadratic. We put it in the format that we are familiar with quadratics. 5x plus 7. Is there some way to get two things that multiply out to be 7 and add up to be 5? No, not by hand. So we use the quadratic formula. Negative b over 2a, negative 5 over 2. Sorry, the 2a's over everything. Plus or minus the square root of b squared, that's 25, minus 4 times a times c, that's 4 times 1 times, minus 28. All right, that's negative. The square root of a negative is imaginary, so this has no solutions, no real solutions. It has two imaginary solutions, but they're asking us for the number of real solutions. None. How about the line before, 3x squared plus 9 equals 0? Let's deal with that one also. 3x squared plus 9 equals 0. I think this one's going to be pretty quick also. I hope you don't mind. I'll just do two steps at once. I move the 9 over, so it's a negative 9, and I divided everything by 3, so I get a negative 3 here. And again, right, x equals plus or minus square root of 3. Oops, but there's an I there, right? Imaginary numbers. So again, no real solutions. Let's look at these four remaining, right? These are all systems, so I have to think of them as graphs. Here we have 2 lines, and the last one is also 2 lines, but so's that third one. The third one is actually the easiest, right? Y equals 5 is a horizontal line, and x equals negative 3 is a vertical line, and of course, they cross once, right? Horizontal and vertical. And then we've got the question of the other two systems of linear equations. I don't like fractions much, so I'm just going to clear out the fraction by multiplying everything by 3 on that second equation. Let me rewrite over here. I'll copy the first equation, x plus 6y equals 12. And then I'm just going to clear out that fraction by multiplying everything by 3. So 1/3 x times 3 is x, and 2y times 3 is plus 6y, and 4 times 3 is 12. And now we have two identical equations. What that means is when you graph, you get the first one is a line, and the second one is a line exactly on top of it. They are the same line. They just look a little different. One of them got divided by 3 on all sides. So there's an infinite number of solutions. Every single point on the line is a solution. And then let's see what happens over here. There's a similar kind of thing. 2 to negative 12 is multiplied by negative 6, negative 4, 24. It looks like we have the same slope here. So let's go ahead. Let's multiply the top by -6. -6 times the top. I'm just picking the easiest way to match the x coordinate. So I get -12x plus 24y equals -36. Oh, the second equation is identical. -12x, yep, plus 24y, yep. Oh, equals -35. So what that means is whatever's going on here, the first line goes like this, and the other line doesn't quite have the same x and y intercepts, but they're really close, but not quite the same. So those are parallel lines that don't intersect. These were parallel lines. Over here we had parallel lines that were the same line. Here there were parallel lines, same slope, right? When you saw, they got the same x and y coordinates, coefficients. So if you solve out the slope by doing the slope-intercept form, you'll get the same slope. I think it's 1/2, but you'll get different y-intercepts. So, okay, parallel lines never touch. Boom. So now we have the final one. The final one is probably the most challenging, maybe. There's two ways to think about this. One is to sketch, and the other is to do algebra, right? We could simply do algebra by substituting one equation into the other, or setting the two y's equal to each other and doing algebra. Perfectly legitimate. What I want to try to do is see if I can make some sense of it by sketching. So that's what I'll try. I'll try sketching. Let's sketch the line. Y equals 5 minus 2x. So that has a y-intercept of 5, right? If I put in x equals 0, I get 5. And then minus 2x means that for every 1 that I go over, I go down 2. That means I'll be crossing at 2.5, like that. All right. So there's that line. And then 3x squared plus 2. Well, when I put in 0, I get 2. And now I kind of know what's going on here, because this is a parabola. It goes up like this. So there's one solution. And I don't really care how fast or slow it goes up, right? If it goes up slow, it'll eventually catch up. If it goes up really fast, it'll catch up soon. If it goes super, 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 super slow, whoops, then it still gets really, really, really fast. And no matter what, you'll cross that other line, right? If you zoom out, basically what you've got is this parabola and a line crossing it like that. So twice, two solutions. Just so you know, you could have done algebra. You could have substituted, you could have just set 3x squared plus 2 equal to 5 minus 2x. That's a quadratic. You would have used the quadratic equation, and you would have gotten a positive number under the square root portion of this one when you did the quadratic formula. The positive part would guarantee that there are two solutions. So algebra is fine. I also recommend, since you've already got it in y equals format, you could have just punched them into your calculator, drawn the graph, and seen that they cross twice. You might have had to zoom out a little bit, but probably not. Probably the calculator, if you hit zoom fit, will be smart enough. None of the others are in the format y equals, so none of the others are conveniently in the format that you can put in the calculator, but this one was. So my little sketching, if sketching for you is harder than using the calculator, use the calculator. Nothing wrong with that at all.